All right, guys, a little more about exponential functions, continuation kind of the last day. So that's a nice view here. 2 to the x, 5 to the x. Which one's which? Okay, the answer's there, so you know what the answers are. But why are these two? Well, because the 2 and the 5 are both bigger than 1. Okay, so that's growth. So growth goes up. So, oh, that's a nice one. And that guy goes up too, so they both go up. So they're both growth. Big numbers equal growth. Right? Now, which one is which? Well, we know that this is this one. Okay? And the reason that one is the purple one, we'll call it, is because it is bigger, so it is steeper. The bigger the base, the steeper the curve. Okay? So exponential growth with a big number has a steeper curve. This guy here, we'll go blue, is going to be the other growth, less steep. Okay, if we had 10, it'd be like this. If we had 1.3, it'd be like that. Got it? Good. Okay, so that's the growth. And then the opposite is true over here. Now, I don't really worry too much about this, okay? These are both decay. This is less than 1. This is less than 1. I have a half. I have a fifth. Okay, they're all exponential because the x is in the exponent. Okay, the x is in the exponent, exponential. Which one is here? Which one is which? Well, the one thing we want to look at is that this purple one here has a base of 5. The one that is the mirror of it is going to have the base of 1 over 5. Okay, so the steeper here is the bigger denominator in the fraction, okay, or the smaller number. 1/5 is smaller, so it's going to be steeper. Not that important. What I want you guys to know is on growth, the bigger the number, the steeper. And these two guys are decay because they are on they are less than 1, and therefore they do this, they have that shape. Okay, they all have the same y-intercept, and again, D and C are growth, and A and B are decay. They intercept 0, 1. They do not have x-intercepts, so my line is horrible here, but they don't cross the x-intercept. Okay, they flatten out, but they don't touch. Okay, they get small and small and small, but they don't touch. And they have the growth factor, decay factor is the base, blah, blah, blah. We'll get to that later, okay? If the base is greater than 1, we have growth. If it's between 0 and 1, we have decay. We never have negative bases, so you'll never have -3 to the x, so don't worry about that. Okay, we're not going to graph that. But you'll have numbers that are big, I guess, bigger than 1, 2, 3, 1.6, 9.4, whatever. Those are growth. If it's between 0 and 1, so 0.6, 1/2, 3/5, and all those numbers are less than 1 but bigger than 0, then you have decay. Okay, this guy's growth, that one's decay. That's it. The bigger the base, the faster the growth, and the smaller the base, the faster the decay. Okay, so again, 1/5 will be steeper than 1/2 because the 5 is bigger than the 2. Okay, next page. Question here, what you're going to do is a little calculator work here. So what you have to do to get all this stuff here is go ahead and sub in these numbers into here. So the nice thing about this is when you do this in your calculator, if you just type in 6100000 times 1.029 and then look for this button, x to the y, y to the x, or hat, we've done that before, and then hit 10 and then equals, this number will pop up. Round to the nearest person, because nobody wants to know what a 0.3 of a person is, okay? So don't worry too much about that, but whole numbers are better than decimals when it comes to word problems. These are your numbers here, and then when you plot them, you're going to see growth, okay? Exponential growth. And what's happening is York region population is growing, and the reason we know it's growing, if you look here, this number here, the one with the exponent on it, is bigger than 1. 1.029 is bigger than 1. That's got the exponent on it. Variables in the exponent, so it's exponential. It's going to grow. Okay. If that was 1.059, it would grow faster. Okay. But that's just what you plot. What's the initial population? That's this one here, which is 610,000. But another way to get that is it's this number here. So let me clear that up for a second. Let me get all this cleared up. what you have is, in general, we have a number, we have something to the power of x, that's this guy, okay? And then we have something in front of that. That guy here, or a value, is going to be the initial value, because this is 1.029 to the power of 0. That's when no time has elapsed. And anything to the power of 0 is 1. So now you have 610,000 times 1, and your answer is 610,000. Or you can just cheat and take that number there. Okay, so that's your initial value. What's this? 25 years, whatever, you jam it in, it doesn't really matter. You put in different numbers in here. Just be careful. The question says N is the number of years since 1996. So don't do this. Don't throw in 2000. Like, don't use that as the exponent. Okay, so some kids do that sometimes. They get like 1 gazillion kids, or a population of like, I don't know what, usually breaks the calculator. Don't do that. Okay, subtract that from that to get 35 years. Jam that in a calculator, you get your new number. And this question is here, if you really had that, how far is it off the actual population? You could subtract, but don't worry about too much about that. Just worry really about how to get these numbers here, and then how to plot it. Okay, and then the decay question here, again, this is decay because that's less than 1. And when you put these numbers into here, you're going to get smaller numbers. So again, 200 times 0.5 to the power of 1 will get you 100. 200 times 0.5 to the power of 2 will get you 50. Throw those in a calculator, and those are the numbers you get, and you'll get that, okay, decay. So that's using this to get these here. The initial value, again, is going to be that 200, okay? Or you can throw the whole thing, 200 times 0.5 to the 0 into calculator, and you'll get 200 either way, and that's the initial value, or the initial pressure. So that's a decay question. That's a population question. That's about it for those questions. Now, let me just do this too while we're at it. Now we're just going to sum things up here, and I really think this is kind of a good thing, a good type of question. So what I'm going to ask you here, is it quadratic, is it linear, or is it exponential? Pause the video for a second if you want, go through it and check. Okay, maybe you want to pause. So just stay quiet. No, I'm not going to do that, because hit pause. You know, this guy here got a squared in, so that's quadratic. This guy here has got no exponents, so that's linear. This has 4 to the x, so that's exponential. Okay, and that's the equation. If you have first differences are the same, it's linear. If second differences are the same, it's quadratic. And if the ratio is the same, it's exponential. So you guys knew the first two, and now you know that the word ratio is key for exponential. This guy's a parabola, this guy's a line, and this guy's exponential. Okay, that's decay, but either way, it is exponential. Okay, I could have that too. Okay, just like you could have a parabola up and down. Graph has a constant rate. Again, rate is going to be exponential. Maximum or maximum, minimum, where did that come into play? That's for quadratics. Graph decreases rapidly for negative values of x. That could be a bunch of things, but that could be either linear or exponential. Okay, I don't like that one. Okay, has a variable exponent, so the exponent is the variable. Okay, so that's exponential. Has no exponent, that's a line. Has a squared exponent, so x squared question like that. It's quadratic. Is never symmetrical. Think about that one for a second. Is never symmetrical. That's exponential. Is always symmetrical. That's quadratic. Can be negative, positive, 0, or undefined. That's what we talked about. Linear. Parabola is quadratic. Straight line is linear. Has a y-intercept and no x-intercept. That's exponential. So I know I'm whipping through this. But pause. Whatever you gotta do, pause it. Which one's which here? Squared is quadratic. Linear. X is up there, so exponential. That's it. Okay.